Hi, welcome back to Moose and Chemistry. This is electron configuration of molybdenum. Okay, when we look at molybdenum, it is element number 42 on the periodic table. Element number 42. So we're going to write 42 for our atomic number. And the atomic mass unit of this element, of course, is going to be 96. We're going to write 96 for our AMU. Okay, here we go. So now, we notice that it has 42 protons, because that's what the atomic number says. Since it's electrically neutral, it's going to have 42 electrons. And neutrons, well, again, remember that it's AMU minus our protons equals our neutrons, right? So we're going to go 96 minus 42, and that's going to give me 54 neutrons. Pretty snarly, huh? 54. Excellent. Now I'm going to go ahead and erase some of this because I like having plenty of space to do work. Yeah, there we go. All right, now we're getting ready to do our electron configuration, but before we do that, we have to remember that the S subshell can hold 2 electrons. The P subshell can hold 6 electrons. The D subshell can hold 10 electrons. And the F subshell can hold 14 electrons. And we're going to be using the off-ball principle, which is the diagonal rule, right? The off-ball principle basically says you have to fill in the lower shells first. So in essence, it's kind of like the diagonal rule in that we have to follow these red arrows down until we run out of electrons, right? So we'll start off with this 1s2. Okay, great. 2s2. Everything's going well right now. So this is pretty amazing. So we're going to put a 2s2 in here. Okay. 2p6 and then 3s2. 2p6 and 3s2. So far so good. 3p6, 4s2. 3d10, 4p6, 3d10, 4p6. Now notice I didn't say 5s2. This is going to be one of those exceptions. So I'm going to put 5s1, right? 4d5. Why didn't you write 5s2, 4d4? Well, here's why. Remember that the 5s shell is actually higher than the 4d shell. So we're filling the 5s first because it only has 2 electrons to fill. So what we're going to have to do is we're going to take 1 away from the 5s, right? Put a 1 there, and because according to Hund's rule, we got to finish out the sub-levels first. So that's going to give me 5. And that's why. Watch when we do our orbital notation. It'll be much more clear. So remember Hund's rule says you have to put an up arrow in every suborbit before you start the down arrow. So here we go. Up 1, down 1, right? Up 1, down 1. 2px, 2py, 2pz. Down, down, and down. 3s, up and down, right? 3px, 3py, 3pz. Here we go down, down, and down. 4s, up and down. 3dx squared minus y squared, 3dxy, 3dyz, 3dxz, 3dz squared. And then we're going to go, of course, down, 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 and down. 4px, 4py, 4pz. Down, down, down. Now, watch this. Normally, people would go, oh, 5s up and 5s down. Then they go 40x squared minus y squared, 40xy, 40yz, 40xz. But look, you're missing 1 right here. You're 1 away from filling that in. So you have to take that away from the 5s. So we're going to take that away from the 5s, and we're going to put it here in the 4d, which is going to be pretty darn amazing, right? Snarls. All right, now that takes care of the y. So guys, let's look at our noble gas notation. The nearest noble gas to molybdenum is krypton. So we're going to put a Kr right here. And then we're going to put in our valence shell after it. Now let's go ahead and do that. It's going to be 4d5, 5s1. Now we're going to look at our quantum numbers. Now, when you think about molybdenum, you think about, hey, it's in the 5th energy level. But it's not. Remember that it's in the D block. And it's going to be n minus 1. So you're going to go 5 minus 1. It's going to give me 4. So our principal quantum number is 4. Our L value is going to be 2 because it's in the D block. So angular momentum is 2. And then what about our M value? You go minus 2, minus 1, 0. The fourth one over, so it's going to be number 1 there. So our magnetic number is 1. And our last arrow, guys, our last arrow is this guy right here. And it's going up. So it's going to be 1/2 positive. Well, that's it for this lesson, guys. You be snarly, and we'll see you back here at Musin Chemistry.